Alright, so the next stuff we're going to talk about are area word problems. This is probably the hardest part in the unit. Reason being is because we have these little things called words that we have to deal with. And I know how you guys feel about reading, and trust me, I'm on the same page. So if I stumble on some words, please don't make fun of me because I'm not that good at English. But number one says, the highest bridge in the United States is in Royal George Bridge in Colorado. I think Gruget made that up, or maybe it was Lavarsky. Either way, it's in Colorado, 1,053 feet above the river. Suppose a marble is dropped from the bridge. How long will it take for the marble to reach the surface of the water? Assuming no air resistance, which if you ask me is a big assumption. Use negative 16t squared plus h sub 0, where t is in seconds and h sub 0 is initial height above the river. Now just reading this problem appears to be very, very difficult, but trust me, it's not. So the first thing I did is I drew a picture here and see, there's Griffin, and I have the Grugs here, and I think it would be 2 G's, Grugs, maybe 2 O's, I don't know, either way. So let's say that I have a marble because I'm more likely to do something stupid like this, and I'm dropping it down. I know my equation is going to be negative 16t squared plus h sub 0. If h sub 0 is the initial height, I know that's going to be 1,053 feet because it says it here. Oh, forgot my square. Good call, Grugs. Alright? That's just copying down this equation, which apparently I can't do. But anyway, I have my equation right here. Make it easier, what I want to do is I just want to look at it in my calculator. So if I go to y equals, and I set this equal to y, I'm actually going to put it over here so it doesn't confuse you. If you put it in the calculator and you graph it, you're going to get something that looks like this. Now obviously, I can't see the top of my graph, but it doesn't, all it wants is it wants where it hits the river. Well, the river is going to hit right here where my x is going to be 0. So even I can change my window so I can see the whole entire graph, or I can just know that, hey, look, that point right there is what I want. So if you go to second and you go to calculate, you can use the calculate buttons just like you did in the last one in order to figure out exactly where my y value is 0. So I'm trying to find my 0 here. It's going to say left bound, and I'm going to move it until I can see it in the window here. I'm still at 800 something in my calculator, so I got a ways to go. Keep pushing buttons, Griffin. Keep going. Oh, there I am. There's my left bound. And then I'm going to do my right bound, so it's on the other side. Again, like in the last video, you see that the y value is negative, so I know it's going to be on the right bound of that. Hit enter. Who cares about guessing? Boom, there it is. So my 0, or my time, is going to be approximately 8.11 seconds. So my t would be 8.11. And let's do the little squigglies in here because that tells me approximate, because I don't feel like writing the 24904 whenever else follows. Alright, for number 2, it says if each of the side of a square is lengthened by 6 centimeters, the area becomes 144 centimeters squared. Find the length of one side of the original square. I know this is going to be very, very easy for you to do without setting up in a quadratic, but trust me, you want to get practice on doing this because they will get a lot harder. As you can see that I drew a square, which actually, since I'm a geometry teacher, I should know that this is a rectangle. But let's pretend it's a square, and I'll put up here if you want to, just to make Gruget happy, not drawn to scale, D-R-A-W, drawn to scale. Alright, so, if you look over here, if I started off with my square, each of them being 6, and I lengthened both of them by 6, that would make this plus 6 and plus 6, because I'm going to stretch them out. If the area becomes 144 centimeters squared, then I'm going to have to set up in a quadratic in order to figure this out. So what I'm going to do is I know the area is going to be length times width, so I'm going to say x plus 6 times x plus 6 equals 144. There are 2 different ways to do this, but I like this way a little bit better. I know if I have x plus 6 times x plus 6, this is going to be x plus 6 squared equals 144. I'm then going to take in my calculator and turn it on, clear out what I have here, and I'm going to say x plus 6 squared, and then I'm going to graph the other side of it as well, the 144, and I'm going to see where these 2 lines intersect. Now, if I have this graph right here, obviously I'm not going to see 144, so I need to change my window. So what I want to do is I want to hit window here, and I want to change my Y max to, let's say 150. Actually, let's say 160, give me a little bit more room. And when I graph that, still graphing, still graphing, still graphing, here we go. I'm going to be looking at this intersection point right here. So if I go to second, calculate, the trace button, and go down to option number 5, intersect, I can come up here to this intersection point. For some reason I like pushing buttons today. Hit enter, second curve, enter, guess, and then boom, right there I have x equals 6 and y equals 144. So x is going to end up being 6, which makes sense if you look back here at your original problem. 6 plus 6 is 12, 6 plus 6 is 12, 12 times 12 is 144. So our x is going to end up being 6. Question number 3. Steve is planting a garden that is 25 meters longer than it is wide. The garden will have an area of 7,500 meters squared. What will the dimensions be? So I want to start off here, and I'm going to draw a picture of my rectangle this time. And I know that if my the width is longer, I'm going to say this is going to be x, and that's going to be x plus 25. Okay. If you want to label all sides, you can do that. It's not a big deal, but we're only going to be using 2 of them. And I know that my total area is going to end up being 7,500 meters squared. Again, I know that the area is going to be length times width, so I'm going to set up my quadratic, x times x plus 25. If I were to distribute that x, that would tell me exactly where I would get it, or where I'd get the quadratic from. And this is going to equal 7,500. Now, there are multiple ways to set this up, but since I like using a calculator and I'm lazy, all I'm going to do is I'm going to enter this in as my one y variable or y value, and this in my other, and again check the intersections. So if you look at my calculator here, I'm going to clear out from my previous problem, which I would do if I was actually prepared, but I'm not like that. So my first one I'm going to say x and then parentheses x plus 25, and my second one I'm going to do 7,500. Now, when I graph this, I still have my same thing from before, I'm probably not even going to get close to seeing this. So I'm going to want to change my window. I obviously know that it's going to be touching somewhere up near 7,500, or at 7,500, so I'm going to make my Y max very, very big. I'm going to try 8,000. Odds are you're probably on this problem going to have to change your X max too, but let's graph it just to see if we can see it now. So after we graph, you can see it's not even close. See how my 7,500 line up here is way up here and I can barely see my quadratic? So I'm going to go back to my window and I'm going to choose something a lot bigger for my Y max. Let's say it, I'm sorry, you're right, X max. Well, let's change that to 1,000. Probably overkill, but it'll do the job. There it is. My intersection is right up there at the top left of my screen. So if I hit second, calculate, and I want to go to my intersection there, I go over to my first curve, I go over to my second curve, come on little guy, hit enter, and my intersection X is 75. Now I ask myself, am I done? The answer is no. I solved for X there, but I'm not finished yet. See, if I plug in X into my picture, because it's asking for the dimensions, I get X is 75, I have to plug it into here as well. So 75 plus 25 is going to be 100. So if you look at the question, it says the garden will have an area of 7,500 meters squares. What will the dimensions be? Our dimensions are going to be 75 by 100. And that is going to be our final answer. Alright, so for number 4 is very similar to number 3. So go ahead and pause the video now and try number 4 on your own and see what we get. We'll give you the answers tomorrow during class. But now let's talk about number 5. This is when things get a lot more tricky. So number 5 says the length of a pool at the local YMCA is 10 feet more than its width. A walkway 4 feet wide surrounds the outside of the pool. The total area of the walkway and pool is 999 square feet. Find the dimensions of the pool. So what we want to do is, just like in your previous geometry class, drawing a picture is going to help you out tremendously. So right here I have my pool, and to help you see a pool, I'll make my little waves. And if you say they look like birds, they don't. They're waves. And here I have my walkway going around the pool. Now, we're going to have to break this up into different parts so we'll be able to see it more clearly. but I know that my total area is going to be 999 square feet. If I read the first sentence again, the length of a pool is 10 feet more than its width. So I'm going to label this x, and I'm going to label this x plus 10. The walkway is going to be 4 feet wide. So I know from this part to this part is going to be 4. But remember, the whole entire walkway is going to have dimensions of 4. So I'm going to say that this is also 4. And I'm labeling the corners here so I can set it up for what I'm going to show you in a second. So all of this is 4, all of this is 4, so on and so forth. Now what I want to do is I know that my length times my width, and I'm looking for this length, or this length and this width are going to multiply together to be 999. I can set up my equation. So if I look here, if I want to know the width of it from here to here, I'm going to have 4 plus x plus 4. So that's going to be x plus 8. Again, 4 plus x plus 4. 4 plus 4 is 8, and I have my x there. If I look at my length, I'm going to have 4 plus x plus 10 plus 4. So if I combine these terms, 4 plus 10 plus 4 is going to be 18. So I'm going to have x plus 18. And these two multiplied together are going to be 999. Just like the previous few questions, if we put this in our calculator, this one in the first y1 and this one in y2, and see where they intersect, it's going to tell us exactly what our answer is going to be. So if we grab our calculator here, and we put x plus 8 in one of them, and we put x plus 18 in the other, go down to y2 and put 999, we're going to graph this and find out exactly where x is going to be. Now obviously again, if we're looking at 999, we're not going to be able to see it, so I'm going to have to change my window. So I'm going to have to change my y max to something bigger than 999. Let's try 1500, just so I can put it in the middle of the screen so you guys can see it a little bit better. And odds are we're going to have to change our x max as well. So to make things easy, let's change that to 1500 too. If I hit graph, and here it goes, there is my 999. Maybe I changed my x value a little bit too far. Let's go back here. Let's try 150. Let's drop one of those zeros. And there it is right there. So I'm looking for that value right there. So I want to go to second, calculate. I want to see where they intersect, choice number 5. And I'm going to move this a little bit closer here. I hit enter for my first curve. I am going to hit my second curve closer to the point of intersection. And I see that my x value is going to be 19. So when I look at this and I plug this back in, we're not quite done yet. So if you look here, I know that one of them is going to be 19. My x is 19 there. I actually have to plug 19 in here. So 19 plus 10 is going to be 29. So my dimensions are going to be 19 by 29. And that will be my final answer. All right, number 6 is probably the hardest one on the page, and this is probably going to be the one you're going to have the most trouble with. So you may need to watch this explanation on a couple of times. But the question states, Bob is fencing a pen along the outside of a wall of his house for his dog. We'll call his dog Spike. So Bob has 60 meters of fencing and wants to give his dog, or Spike, the greatest possible area. What should it be? So it gives us a diagram here that pretty much is going to set us off. This is his house right here, and I know it's not a very good house because it's kind of flat, but there's his house, and he wants to put poor Spike inside of this rectangular fence. Because we know it's rectangular, we know that these two sides are going to be the same. From here, we need to figure out what this side is going to be in order to maximize the area. So what I want to do is I want to look at my fencing. So here's my fencing right here that I have. I know that this part right here is going to be X. And I know this part over here is going to be X. And I know that the whole entire thing is going to end up being 60. So what I want to do is I want to figure out how much this right here is going to be. Well, if the whole thing is 60, and I have two parts of 2x, I can label this as 60 minus what I already have, which is 2x. So if I label this part up here 60 minus 2x, this is going to give me a length and a width that I can multiply together to find the largest area. So what I'm going to do is I'm going to say, okay, I want x times 60 minus 2x to be equal to my largest area. From here, I'm going to pull out my calculator and I'm going to graph this equation right here, and I'm going to find my max because I want my maximum area. So if I say x times 60 minus 2x and I graph this, this will be a downward facing parabola. Obviously I can't see it, so the first thing that comes to my mind is I need to change my windows. So if I take my window here and I move my x max, let's say 30, and I make my y max maybe 100, and I graph this, hopefully I'll be able to see my parabola. Now, as you can tell, my x values are really good, but my y values are not even close. So I'm going to take my window, go back down to my y max. Let's try 300. Now once I graph it, hopefully now I can see the top. Still not good enough. This thing's going to be pretty hot, pretty high. So change my window. Let's get nasty on it and change it to 1,000. You better be in my window. Oh yes, there you are. Alright, so now what we're looking for is we're looking for the maximum area. So we want to find the biggest area. So what I'm going to do is I'm going to go second, calculate, and I'm going to find the maximum of that parabola. So when I hit maximum, it says left bound, so I go near the top, the left side of it, right bound, go near the top on the right side of it. Forget guessing, go straight to it. So my maximum is going to be an area of 450. The question asks, what should x be? Well, right here, x is equal to 15, so that is going to be my answer. X equals 15. If it wants the dimensions, all you have to do is plug 15 into this and figure out what it is, and that'll be there. But the question's asked, plain and simple, what should x be? So the answer we'll stick with is x equals 15.